Okay, we come to our content. So welcome to the course Electrical Engineering. Okay. So my name is Ajak Kirati Chayakun Kiri from School of Electrical Engineering. So you can contact me by. So for this class, you can contact me on my TA to the Facebook group, okay, or you can direct message to me as well. You can see my account in that group already, I think, okay. And my office is in C1 building, C1 building, and fourth floor. And at this time, the building is under renovate. It's quite difficult to get access to the building. This is my email. You can send an email. Okay. So I think no problem. So first, usually student contact TA first, right? Not the instructor, right? You feel better to talk with TA better, right? To the teacher, right? Okay. So let's see the content. So this is for electrical engineering. We will talk about principle of electrical engineering. We have DC and AC circuit. Okay, I think you learned something, right, about this. Direct current, alternating current. We have to do so many calculations, but I'm not going to do complex detail. Just to get idea what is DC current, AC current, what is it, what you should know about electrical engineering like this, right? Then we learn about the magnetic circuit, transformer, matching, electronic device, circuit, logic gate, IC, and control system. Too much. I think it's too much for you. You see, usually we learn this one term. In one term, for electrical engineering student, they learn in one term, but we put in one topic. Right? So it's very tight for you, but what I can do so is to just make just overview, not go too much detail, right? And magnetic circuit and this and to this. This also electric machine. We learn about transformer, motor, generator, magnetic circuit. We also usually we need one term or one semester. Electronic device and circuit. This is also usually one term. Logic gate and digital circuit. Also, we learn about digital circuit, electronic device transistor, and control system. This is difficult. Okay. But the electrical engineering cannot take this course. This is the old course content. So it's just a broad general. So I separated it into two parts, right? Electrical engineering, DC, AC circuit, magnetic circuit, electric machine. So first I will skip this part first, because this is no laboratory for you. If you go to laboratory, you will do AC, DC circuit, electric device, like this. You do something about circuit and electronic circuit. Okay, maybe until diode, maybe electronic circuit, transistor and diode and op amp. And diode. Op amp. Yes. Please note that this content is not designed by me. It's not by myself, but by your school. Okay. It's by your curriculum. The curriculum is designed by your school, not me. Okay. So if you feel it's too much, don't tell me. Tell your school. Okay. Okay. Because they want to merge everything into one course. This when I also need your program coordinator. And he said that I want my student to learn this and also this within 2 credits. So, within 2 credits. So, and also sometimes you may feel that why I need to learn electrical engineering. I am not going to be electrical engineering, right? But me too. I also learned about thermodynamics, about, right? About thermodynamics, about mechanic, right? Engineering mechanic. So I also learned about economics, statistics, right? It's good to know about electrical engineering for all engineering, right? For all engineering. This is the basic knowledge. It's make you be able to work with electrical engineer very well. You will understand what is AC, what is DC, right? What is the power, what is the signal come from, right? In your work in the future. Okay, and maybe you're interested in this slide, right? So my the grading system will be this is for lecture part, right? Lecture part, midterm 40%, final exam 40%, homework assignment for 20%. We read the lecture and lab will be read some way. Usually 65, 35, 60, 40. Okay, let me talk with my team. Okay. For the grading system. Okay. This is textbooks. Okay. This is a good book for you. Okay. I will mostly follow this textbook. Okay. And I said this is the book for non-electrical engineer to learn about electrical engineering. Okay. So many content here, but I'm not going to cover all. It's not possible to go on within one term. Okay. I will skip this introduction part, and I says that you learn a lot already, right? So you can get access to many information from internet right now. Okay, this is just history of electricity, right? Electricity. So many years ago, right? From this year is 2026, right? So more than 400 years ago, we know about what electric charge come from, right? And then we study a lot and try to utilize this phenomenon, right, from the electricity charge. So we know about the electromagnetic. Then we know the relation between electricity and magnetic, right? Electric field and magnetic field is, and we can use this in many ways, right? Both in power or in a signal, right? Okay. And the first utilization of electricity to the light is from Edison. You know Edison, right? You heard about Edison, and he is well, invent the lamp, right? Incandescent lamp, right? To change electricity to the light. So at that time, we start using electricity in households, right? Not just only in the laboratory, but in the real household. And nowadays, we have the electrical system, right? In many countries, most of the countries all around the world, right? We have the network, electric network, right? All around the world in every country. Okay. And after that, we start using AC system, alternating current system, right? Invented by Westinghouse. Firstly, we use electricity in DC flow, right? DC system, direct current, like the electricity from battery, right? From battery or DC system. After that, we change to use the AC system. You know why? Why we are using AC system? Why not DC? You know about the difference between DC and AC? The voltage of DC system is just constant, right? Just 12 volts or 24 volts, whatever, according to the time. But for AC system, what about AC system? Sine F, but why we use AC system? We have both type of electricity, right? But why we use AC system in most of our facility? This is DC, our DC system from battery, right? DC. This also DC, right? You need some power supply, right? Change AC to DC, right? What about projector? We also need AC to DC converter, right? To change to DC electric circuit. What about the lamp? Nowadays, it's already LED, also electronic system, right? It's electronic. It's not like fluorescent anymore right now. It's electric system. But why we choose AC system? But we need to convert to many equipment. Like TV, like mobile charger, like many things. The end use is become DC device already. But why still we use AC system? Any idea? If you walk into the plant or the factory, or into the big building, or if you walk into the factory, the manufacturing process, so we see both AC and DC electricity, right? But the main income to the building or to the factory, mostly in AC. Why? No idea. Any idea? We use AC because earlier we can convert the voltage easy. Okay, the voltage can be converted, can be step up and can be step down by using the device called transformer. If we have transformer, we can convert the voltage like 10 volt to 220 volt. We can step up, we can step down really easy. Yeah. When we transmit the large amounts of electricity, we step up the voltage into high voltage. If we have high voltage, we can send lower current, high voltage plus low current for high power. Right? When we want to transmit the electricity long distance, we step up to high voltage. The current will be lower. Will be lower, and we can transmit the long distance with the lower loss, right? So the network, electric network, will be AC system until the end use. When we come to end use, many devices nowadays become DC system. Okay, DC system mostly. Okay. And maybe in the future, with the power electronic device, power converter. With power converter, we can convert DC to DC system. Maybe we back to use DC system again with this technology. With the focus on power electronic technology. Because we can convert DC voltage easier than before. And we also use electricity in many forms, right? For example, radio signal, like electromagnetic system. Programmable control computer, we use its computer, we use the signal, right? So that way you also learn about the electric signals, right? Transistor, this is a very important device for electronic engineer, right? You learn about transistor here in this class. Here we talk about transistor. Here, about midterm, just before midterm, we touch on transistor. You do the laboratory with this type of device. How it works, right? I would like you to understand how it works. For transistor. And then we have IC, integrated circuit, or we call IC. IC will integrate many transistors into small device. We have electronic. If you learn about transistor in the laboratory, you connect many transistors together to get a circuit to do something. Okay, this circuit to do something, to control something, to drive something, to drive motor, to drive the display or something with this type of equipment. Okay. But in fact, we can use IC, we integrate so many transistors inside. Okay. This is a big progress on human technology. And then we will have microprocessor which integrate many IC into this. So now we talk about electricity. We utilize electricity in many forms. Right? First, we use electric power to send the power, to transfer it to the power, to change to the light, to change to the motor, to change to the heating system. But we use this as a power. We can store this power now in battery, right? We can store electricity. We can send electricity. We can use this as a power. If you transmit the power, you can transmit in many ways, right? You transmit right to fuel, right? Gasoline. But you can change it to electricity and transmit electricity instead, right? Okay. Transmit electricity from in power form. Okay. Storage, distribute, creation is generation. Generation. generation, and then transmission, and then distribution, and utilize this as an energy, power and energy of electricity. And we can also, nowadays we can storage electricity, right? We call energy storage system. ESS. Okay. So many forms to store electricity, like battery, hydrogen, right? Or hydropower. Can store to hydro station, right? To pump the water to the higher level. This is store the energy also, right? And then we discharge the water through the generator, right? Past the turbine, and the generator can back generate electricity. Okay. So we learn electrical engineering. We learn a lot of this process. Okay, process. And sorry, my school doesn't have international club yet. You may be interested in change to study electrical engineering, right? But sorry, we don't have that curriculum yet. Okay. Because we have too limited teacher. Okay, we have local student is already enough for us. Okay. Also, control system design and using control for the system. We use signal for control to measure the temperature. To measure the temperature, for example, the light temperature, we convert to voltage signal, right? For control, right? So any signal like pressure, velocity, right? We can convert to current or voltage, and then we make control. Electronic and microelectronic design, selective microprocessor, which is about electrical engineering and computer and electronic engineering. Signal processing analysis. This is used in many fields of study. So I myself, power engineer for me. So some of my colleagues is a control engineer. Someone is the electronic engineer. So it's not mean we know all electrical engineer, right? I have very limited knowledge on electronic device, for example. Okay. But I start my study based on power generation and transmission, right? Yes. Okay. And some of my colleagues have the skill signal processing. Right. So we need to analyze this signal. Okay. And also we have telecommunication engineer. This is the mobile phone, right? Smartphone, right? But nowadays we are shifting to digital communication. Digital communication. So, satellite communication and computer design and development of computer system. Instrumentation, data acquisition, sensor, measuring device. So, okay, so many things. And it's good to you to learn. Okay. And I think that just by this past few years, I think the learning system will be changed very much. Right? I think you also feel that you can access to many generative AI. When you want to know something, you just talk with generative AI, right? When you do homework, you just upload the homework into the generative AI. You get the result, right? If you do that, you will have problem in the examination. Sure. Okay, so you use generative AI as your assistant, right? Assistant to check the answer, right? You do the homework by yourself, you check the answer. But many knowledge like this you can get from the internet, right? From the AI. There's a lot of knowledge in AI. When I talk to AI assistant, I feel that it's know a lot, know many things. We need to analyze by ourselves. We come out with something. I think human knowledge or human feelings will be important to handle the system. Okay. Okay, now we come to the basic concept, right? And we have electricity, charge, current, voltage, power, and energy. So we have this term in this course, okay, electricity, but we will talk about, but I will not talk about the charge very much. Right? In Coulomb, you study physics, but we learn about the current. Here we use variable I, voltage is V, power and energy is P and E. The phenomenon of electricity is the move of the charge, as we have already learned here. We can observe, experience the charge. Yeah, this is usually in physics. But in this course, I will focus on the current blood. Okay, current I is the moving of the charge per time. This is moving of the charge. But how it's moved? You learn in physics, right? Okay. But here we try to solve in terms of application now in this course, right? In application, not basic science. Okay, we study based on application. Okay. So in the basic electric circuit, usually we need two types of device, right? Which is the source and load, right? The battery will be paid the load. For example, battery is source, and then this is the device or the load. We also call the source device as the active device. And the load, the passive device. And we have so many types of active device. For example, battery. And many passive device. Passive device is a device which consume the power, right? Utilize the power, like this monitor, this lamp, this projector. This is passive device. And the active device, for example, this laptop, you can get the power, right, from the active, right, from the battery, from the source. And we need the circuit to make it work. Right? We need the circuit. We need the contactor. Get it to the circuit. and it will work only for closed path. Right? If we talk about the circuit, it would be closed circuit, which will work, right? If you have battery into lamp, if the circuit is open, nothing happens, right? It should be nothing. And it's no electricity flowing. We have the closed circuit, the closed path. Close the circuit is okay. This will work. We can calculate, right? Then we can analyze this. And we have the analysis of the circuit in many ways. Right? In many ways. For example, if you have battery to lamp, right? For example, 10 volt, and we have this is 5 ohm. So you can calculate the current. How much for the current? This is easy, right? How much for the current? 2 ampere, right? 2 ampere. Too easy for you. 2 ampere. Then 2 ampere. But sometimes, and what happened? This is DC voltage for 10, and you will have the current for 2 ampere, right? Right? And if you switch on this, the voltage is 0 until you switch on, it's become 10. What is the change of current? It's switch on. T equal to 0. This become more complex, right? What happened to the current signal is not, it will not, we take some transient system. Okay, the same concept transient. We have steady state circuit, and we have transient circuit. So for ecology, we need to learn a lot this phenomenon, not only that. Okay, and you will touch something on this in class. Okay. And when we talk about the current, is the direction is there. The direction of current is there. If we notify the current I1 with this direction, the current I2 will flow in, if we denote is in opposite direction. So we can say I1 equal to minus I2. Okay, like we calculate this variable in vector form, right? So the direction is there. The direction will denote by sign, plus or minus sign. This is very important. Very important when you solve the complex circuit. Okay, when you solve the complex circuit, it's very important for you to denote the direction of current and voltage. Okay, and we have direct current and the AC current. Also the voltage. VA into B. If we say it's the positive direction and negative direction at A node and B node respectively, and VBA would be the positive direction at B side and negative at A side, and VAB will be equal to minus VBA. Similarly to the current. And when we solve the circuit, we need one. We usually need one reference. Yeah. And maybe we define it as the ground reference. Is reference node. Okay. Okay. And for the voltage, physically is joule per coulomb. We call volt. Okay. And for power is joule per second, or we can call watt. Usually electrical here we use watt rather than joule per second. Is the product of current and voltage, right? I think you learned about this. P equal V into I, right? It is in volt and I in ampere. And the unit of P is usually in watt. Right? And this is an example of schematic electricity system, right? We have battery supply to the lamp, right? And we have switch, this switch here. We call this as equivalent circuit, right? Model or equivalent circuit. To solve something, to calculate something, we need the equivalent circuit or the model of that thing, right? To solve this circuit, what would be the electric current flow? For example, we need to make it in model or equivalent circuit first, right? How much the voltage, how much for the resistance, right? For the resistance. So we call equivalent circuit. Everything we transform into equivalent circuit first, right? Like for civil engineer, when you look to the bridge or the building, what do you look for? Moment, the force, right? Vector of force, or vector of force, just like that. No? Okay. For mechanical engineer, when you look to the some system, mechanical system, what do you look to? Right? When you see some mechanical system, you don't see them. Okay. You see something. The formula is there, right? Is there any formula there? No. For petrochemical, when you see some process, petrochemical process, what you see? So many chemical formulas come, huh? No? No. Well, for electrical engineering, when we see the transformer, we see it into the circuit. When we look to the transmission line, oh, R and L are resistance, capacitance. The variable is there, right? No. Before we solve something, we transform into our model, right? Based on your professional knowledge, right? We try to change it to equivalent circuit first. As for this course, we change everything into the circuit before we solve, right? So we have resistance, we have capacitance, we have inductance, and so on. Okay. Here, this is the symbol of the device in electronic and electrical, right? We have diode, we have capacitor, we have inductor, resistor. So this is maybe in the integrated circuit because this is logic gate. So have you ever learned about this? No. Some. No?
High school.
High school. High school, no. This is also high school. Okay, good. This is the resistor, and this is the symbol, right? In the equivalent circuit. This is okay. That is the mathematical. And this is the resistance. Okay, this is side of resistance. Like this. In fact, we have many types of resistance, not only this type. Okay, but for this resistance, is usually in the electronic circuit. The color band will indicate the resistance of this resistor of the resistor, right? Of the resistor. So we have resistivity of the resistor. The resistance will indicate in ohm, right? Here. The color band will indicate is the resistance. I'm not going to this. You will learn how to read the value of resistance in the lab. Maybe tomorrow, right? Maybe tomorrow. But some of you may be familiar with this color band already. Yes. When you pick up one resistor, how much for this resistor? You need this cable. Okay. But you don't. I don't know. Do you need to remember or not? In the lab, when you careful of the lab test, right? And based on Ohm laws, right, the current will be a V divided by rho L. Rho L divided by V is the resistor. Right? This is here. And A rho L, I think you learn already in physics, right? And the A is the cross section area, L is the range, right, of the material. And this can be this resistance. R is rho L by E, right? And based on Ohm law, V is I into R, because when he make the experiment, V and I, when we measure the voltage, when we supply some voltage into one device, this is voltage, measure current. When we vary the voltage, the current vary in according to the voltage, and you can get some curve like this, right? And the slope will be the relation between right? V equal to R into I, right? This is 1 by R. Okay. And we also have the device called capacitor. So we talk about capacitor also. Capacitor is a kind of storage device. It's a kind of storage. Storage the charge. In between some surface, right? Between two surfaces. Here is capacitor. The symbol is this. It's like this. It's kind of storage. It's a passive device, storage device. Resistor is the power consumed device. Resistor is power consumed. When you pass electricity to the resistor, it will heat up. It dissipates. It consumes the power. The power is gone, right? Okay, the power is gone. But when you supply electricity to the capacitor, ideally it charge the power, charge the electricity to itself, and waiting for proper circuit to discharge this back. Okay, so it's not consumed your electricity, it's stored. Right? It's stored, it charge and discharge, charge and discharge. No power consumption in this type of device. Okay? It's a storage device. I'll back here later. I will talk about inductor. Inductor is also storage device. Yeah. It's passive and storage device. This is a type of inductor. We have many types of inductor. This is a symbol of inductor. Okay. This is the symbol. Okay. Finally, we have resistor, capacitor, and inductor. Yeah. And this is the symbol. And this C and L is storage device. And this is power consumption. It's not solid device. All of this is the passive device. Okay. Three types of basic passive device. It's a resistor, capacitor, and inductor. Capacitor and inductor is storage device. When you supply the power to the resistor, it will heat up. Okay, but when you supply the power to capacitor and inductor, this will store current. So then what happened? We put the battery into the capacitor. First, it will store the current. So then the current will flow first. Will flow until it become full charge. If it's fully charged, no current flow anymore. Okay. So if the voltage here, for example, if the voltage is 1.5 volt, it's fully charged is 1.5 volt. The voltage of the capacitor, VC, right? VC, if VC is here, what happened? It will be charged until full and then 1.5 volt, right? And what about the current? The current will flow until the voltage full, the current is 0, right? No current anymore, right? This is it. Current flow here. So firstly, the current will flow until the full charge, and then no current flow anymore because the voltage is staying. So the voltage is like this, and current increase until 0. So this voltage, this circuit become open circuit. If nothing change, the capacitor become open circuit, right? It's already full charge. Okay. So if you connect this circuit, what happened to the lamp? The lamp will turn on at the beginning, right? After that, no current flow is become off, right? The lamp will turn on and then off, right? This is on, then off. Okay. Let me learn how to calculate about this type of circuit. And for the inductor, similarly, if we supply to the inductor, we power supply to the inductor, it will store in the term of magnetic field instead of charge in magnetic field. After we supply the circuit for a long time, the inductor become short circuit. For example, if we supply 1 ampere, it become short circuit. Okay. So with this circuit, if we first switch this, the current will flow into two parts because this will be some the magnetic circuit is not fully charged. Yeah. And it also flow from past to the lamp. After some time, when this inductor fully charged, it becomes short circuit, right? It's become short circuit. So if you switch on this circuit, the lamp will turn on for some short time, right? After that, it's turned off because the circuit bypass the lamp, right? It's bypass the lamp first, like this circuit. Then we turn on and then off. Okay. And also we talk about transformer and alternator. This is a magnetic circuit. So let's see if we can come to this part or not. And for the source, we have many types of electrical source, right? Voltage source, current source. You learn about current source in some circuit. No, never. Okay. So, and the voltage source will supply constant voltage, for example, 12 volt, right? Like the battery, right? And you may not familiar with current source. The current source usually is only in laboratory. So we not in our real life, it's very rare to see the current source, right? It's constant current source where it supply 10 ampere constant. So it's usually from the power supply in the laboratory, right? Or in the battery charger. Battery charger sometimes require constant current to charge the battery. Okay. And this is a control source. Control source means this source is controlled by some parameter and control current source. Okay. As well. And this is a symbol for the battery cell. The same symbol for the voltage source. We can use this symbol or even this. For the ideal source, it supplies constant voltage to the load, like this. Or we call independent voltage source. The source never changes the voltage. But in fact, if you load the power in your real life, the battery you have internal resistance. This is 1.5 volt. If you measure by voltmeter, you get 1.5 volt of this battery. But when you take the current if the current flow. You have internal resistor here, and the voltage is less than 1.5 volt, right? When the battery discharge the current, usually the voltage is brown. But in our calculation, ideally we consider is constant voltage. Okay, constant voltage. Also for the current, for the current source. As well, we analyze that constant current source. It's the ideal current source. And this is a control voltage source, control current source. So for example, is for this type of source, the 5 volt, this time maybe 5 of Vs volt, but it depending on some variable dependent source, because dependent source or control source. Okay. I think this is, I can skip this video circuit. You can see the example of resistor in series. So you learn about this, it just plus it together, right? If we connect the circuit in series form, this is series circuit, right? What happens if one bulb is broken? It's broken. The circuit is become disconnect, right? This lamp will turn off as well. Okay. This is a series circuit, right? In series form. Here we just plus resistor together, right? Resistance together. But for the voltage, we plus the voltage together if we connect the circuit in series form. It's a voltage source. But for parallel circuit, here. We if we connect the lamp in parallel, if one lamp is broken, another lamp can still work, right? So usually in the electrical system, we connect the circuit by parallel circuit, right? We parallel this lamp to this device, right? To different device. That is from the receptacle, right? From the system, comes like this. So, and we have the method to calculate the current, or we can get the equivalent resistance of this circuit. Okay. You also can connect the voltage source in parallel circuit, right? And we get the same voltage, but we have larger energy, right? Storage. I think you have already have the basic idea about this calculation. So I think next time, right? I think next time I will talk about fundamental of electric circuit. We start calculation next time. Okay? So now you know which knowledge you need to remind yourself already, right? What we will talk about this class. So next time we see in another room. This room or another room. Another room. Another room. Then see you. Bye.